Hello everyone. Today we're going to be talking about some basic tools, which are units, how to convert between different kinds of units, and how to make estimations. Units are the language of the measurements that we make. In order to speak the same language, we need to have a system which defines which measurements that we're making. This system of measurements has defined these 7 different kinds of units to be the most basic and also to be based on fundamental properties of nature. So you can look at these 7 different units. We have the length, the mass, the time, amount of substance, temperature, electric current, and luminous intensity. Throughout this semester, we'll focus on these first 5 units. Next semester, we'll pick up with the final 2 units. Now there's some other different kinds of units that we'll talk about this semester. The volume, meters per second squared, for instance. These are derived from more than one of these 7 basic units. So we're going to start with a basic conversion between meters and centimeters. And how to do this is basically by multiplying by 1. When you multiply something by 1, you don't change whatever it was that you originally measured. For instance, this 1.8 meters. So now we need to know what this 1 is. And that 1 is that in 1 meter, we have 100 centimeters. And so then we can rewrite this relationship as a ratio. So in 1 meter, we have 100 centimeters. And that is our 1 that we're going to use. In this case, we want to take this 1.8 meters and multiply by this 1. But we need to be a little careful in that when we do this multiplication by 1 is that we're ending up canceling out whichever unit we wanted to get away with. And so here we need to put the meters in the bottom. So then you put the 100 centimeters in the top, and we end up with 180 centimeters. Now let's convert between SI units, meters, and into centimeters, into inches. We're going to do this in 2 steps. So we're given this 1.8 meters, and for instance, let's say our friend wanted to know how tall they were. They had a measurement, they were 1.8 meters, but now they want to know what is that in inches. So we're going to do the same thing, but in this case our 1 is going to be that there are 2.54 centimeters in 1 inch. So we're going to take this 180 and divide it by this 2.54 centimeters. So we're going to end up with 71 inches. Now the one thing that you do want to be a little bit careful with is when your units have an exponent. And in this case, let's say somebody told you they measured the surface area of something and it was 100 inches square. You want to know what that is in centimeters squared. So you're going to multiply that by the same 1. Here we're going to take this 1 inch. And in this case we put the inch in the bottom because we're wanting to get rid of the inches. And we're going to multiply by 2.54 centimeters. But in this case we had an area, so we have inches squared. So what we need to do is to square our 1. So this will give us squared inches in the bottom here, which will cancel out with these inches up here, and will give us squared centimeters. So we end up with 645 centimeters squared is equal to 100 inches squared. Let's say someone asks you how many piano tuners live in Chicago, or what is the strength of the atomic bomb that was detonated at Trinity. And this is one of the questions that was posed to Enrico Fermi, in which he used these basic techniques, which I'm going to teach you, and able to come up with a reasonable estimate for this. Our toy problem that we're going to work with is, what is the volume of air that I breathe in a day? A few assumptions to draw on some experience that we have had in our life. So one thing that you can think about is how many breaths does it take to blow up a balloon? So I'm going to guess maybe 10. 10 breaths of air will fill up one balloon. So what's the volume of a balloon? Well, it has about the size of a soda bottle, which has a volume of 2 liters. So we know that 10 breaths of our air is about 2 liters in volume. Another thing that we need to do is to relate this volume with the amount of time. So here we want to know how much breath do we breathe in a day. So now we need to know how many breaths do we breathe in a second or in a minute. Minute may be easier to deal with, so let's work with that. So let's say that we have 10 times that we breathe in 1 minute. So right now we have 2 relationships that we have, just drawing on some real world experience that we have. And in this case, these look really familiar into these unit conversions that we just talked about. So here we have 10 breaths for 2 liters, and we also have 10 breaths in 1 minute. Okay, so then putting these two together, we can cancel out the breaths, and we can get that we breathe about 2 liters of air in 1 minute. So the way I did this was I just took this second relationship, and I flipped it upside down, and I multiplied it by this, and these 10 breaths will cancel with these 10 breaths, and I end up with this relationship, 2 liters in 1 minute. And here again I have just this relationship 1 basically. So I'm going to guess that I breathe 2 liters of air in 1 minute. So the final piece of information that we have is this day again. So what is the volume of air I breathe in a day? And now the problem becomes very simple now that I made this assumption. So now basically all I need to do is to figure out how many minutes are in a day. So I'm going to do that first by getting this into hours. So there are 60 minutes in 1 hour. And so this is going to give me 120 liters in 1 hour. And so then, in order to find out how many breaths I breathe, how much volume I have in a day, is going to just give me this 120 liters in 1 hour. Sorry. And then now I need to multiply that by how many hours are in a day. So 1 day, put that on the bottom, and then there are 24 hours. So when I multiply these two, I don't really need to multiply by 24, it's easier to multiply by 20. So I'm going to get about 2,400 liters of air in 1 day. All right, thank you for your attention.